Okay, so we have now seen that the harmonic series diverges. Yet if we put an alternating sign in front of it, minus 1 to the k, or k plus 1, either one, over k, then that series we've seen actually converges. Right? So dropping the alternating sign, we have a divergence series. By inserting it, we have a series that converges. In a similar manner, we know that the series 1 over k squared, right, being a p-series, converges. And by the alternating series test, we could also show that the series minus 1 to the k plus 1 over k squared also converges. So in the one sense, the alternating sign was necessary to make it converge. In the other case, if you drop the alternating sign, it was still going to converge anyway. And so what we want to do is distinguish between these two situations here. These two situations where the alternating sequence converges and its underlying sequence converges. And then the other case where the alternating series converges, yet the underlying sequence diverges. And so we're going to do this by describing something that's called absolute and conditional convergence. And this is going to be an important idea when we get into the next chapter and we talk about something called power series. Something called power series is just when we're going to take this idea of an infinite sequence being added up and say, what if we make a polynomial that's infinite and add up all the terms? When would that converge to a particular number? So that's power series. That's coming a little later. And again, this idea of absolute conditional convergence will be important when we get there. But for now, it's basically kind of trying to tackle the differences between these two problems. Okay, so here we have the idea. We say let the series AK be an infinite series. Now, for the most part so far, when we've been dealing with series, we've forced the underlying sequence to be positive numbers. That's mostly what we've dealt with so far. But now we allow for the possibility that AK could be negative. AK can be negative. And it can be negative sometimes and positive other times. Okay. So it can be anything like that. Then here's what we say. If the series of the absolute value of the AK terms converges, so if the series where we take the absolute value of the AK terms, if that converges, then we say that the series AK converges absolutely. Converges absolutely. Okay, so that's our first definition there. Okay. That if the series of the absolute value of the terms converges, we say that AK converges absolutely. Okay. And now there's a quick little fact here that we can now bring into play, and that is if the series of the AK converges, if the series of the AK converges, then the absolute value of the AK, then we know that the original series will also converge. Also converges. Okay? In other words, if it converges absolutely, then the underlying sequence, when you drop the absolute value, that sequence is going to converge as well. That sequence is going to converge as well. Okay? So we don't have to worry about any negative signs or anything there. Basically for us, if the underlying sequence converges, then of course consequence here is that the alternating series will converge. So because that one converges, it's a necessary fact that the alternating one converges as well. Okay. Now we say if, second definition here, if the series of the absolute value of AK diverges and the series of the AK where we drop the absolute value actually converges, then we say that the series of the AK converges conditionally. It has conditional convergence. We say it converges conditionally. We say it converges conditionally. And that's what we're seeing here with our harmonic series. Our harmonic series is converging conditionally, right? Because the underlying sequence, when we drop that sign, diverges. Okay. So we also go in here and highlight my fact here again. If the positive term series converges, again, the underlying sequence converges. And that was what we saw there with the original one. Okay. So that series is going to converge there because the overlying one also converged. And now, if the sum of the absolute values converges and the sequence without the absolute value, if the sum of the absolute value diverges and the sum of the sequence converges, we say it's conditionally converges. Now, there's one little furthermore fact that we can throw in here. One further fact that we can throw in here. That is that if the sum of the AK sequence, where we again are allowing positive and negative terms, whatever, diverges, right, where we're allowing in the negative signs, then by necessity, the other thing has to also diverge. So it gives us kind of another way of checking things. Right? If the AK sequence diverges, then when we do the absolute value, it's going to diverge as well. Right? It's going to diverge as well. So that's another little test here. That if this actually diverges, the alternating, if it's alternating or whatever it is, diverges, then the overall sequence itself is going to diverge as well. Okay, so that's kind of another condition. So if we went back to our example where it diverged, this alternating series diverged, then if we drop away the absolute, the alternating sign, and just look at the sum of that series, it's automatically going to diverge. It's automatically going to diverge. And actually it will diverge, of course, as well by the divergence test. We would actually get that by the divergence test. But since the alternating series diverged, then when you drop the alternating sign part, that sequence will also necessarily have to diverge. So basically there are three kind of scenarios that we have now with convergence for a generic series. And that is, it converges absolutely, meaning that the sum of the absolute value of all those terms converges. Or it converges conditionally, which means that the sequence we're looking at converges, but when we apply absolute value, it diverges. Or the sequence diverges. Or the sequence diverges. Okay, which again is then going to necessarily mean that the original one will diverge. The absolute value one will diverge as well. Okay, so this is absolute and conditional convergence.